Hi, the task 3 is to implement CNN model for a spam text classification dataset. So I'm running run the code first because it takes some time. So here we have taken spam CSV, which was told us for a take, and according to that we have split the data in V1 and V2, which are the columns, and then we created the model and fitted it according to it. Before that, in the V2, if you look at the spam, V1 is just one or two, and V2 is set of words. So all the set of words has been tokenized. Generally, like normalization is been done on just the one column, and I have only selected the two columns out of five, I guess. Yeah. And coming to labeling, so I have labeled V1 encoding, and then I have splitted and then using TensorBoard I got the logs and predicted the score and accuracy. So for each epoch, I want to show you the difference is for each epoch you can see its loss is 4.1 and accuracy is 0.86, and for second epoch it's 0.3 and 0.8. So the gradually it will decrease in loss and increase in accuracy, and it's a very less negligibility, and you can see the average which varies in all the epochs will be the same, and this is for CNN. And one second, let me pause this one. So once I run this command, so I get the TensorBoard graph for the score for the loss and accuracy for the CNN on spam dataset. You can see just got it, and so here is a graph for loss, accuracy, and loss. You can see the difference between see epoch Z1 I'll get the same value as here 0.346, and last will be like 0.269. So you can clarify here is 0.269, and accuracy will be 0.8744 for the last one. For the last good one, 0.871, just like here. 0.8744, 0.871. So you can see the change. And when coming to the task 4, which is to implement LSTM model on the spam text classification. So I have done this on both tasks. So because the next question is to compare the results of LSTM models and CNN model. So that's why I'm just putting this aside to show the differences. Take some time. Let me copy this one. Uh, you can see when I'm running the LSTM model for the same dataset, it takes a lot of processing time when compared to CNN. For just one epoch out of five, it's going to take a lot of time rather than CNN. So I prefer this LSTM model is not recommended for the deployment of any product, because when we are deploying it, if it takes a lot of time, it's going to the outcome is going to be not so good results. So here you can see the change. It's for the loss it's 0.201 and the accuracy is 0.92 for the first epoch. For the second epoch you can see there's a there is a very drastic change in the loss, and there is a high value increase of accuracy. This is for the just for the LSTN. So you can see the changes between each epoch. I have taken 5 epoch because it's taking a lot of time whenever I compile it or run it. So you can see for each epoch the loss is going to decrease, and at the same time accuracy is increasing. And the average epoch for is 0.081 and loss is 0.081 and accuracy is 98, almost 0.98. And if I show the graph for this using TensorBoard, so previously if you see previously I got the average is around 0.876, and right now I got high accuracy when compared to CNN. And you can even see there's a loss decrease in loss in such a way that which is even negligible. And then you can see there is a very good accuracy, but it takes a lot of time to compile each and every time, each and every epoch, and it increases average processing time, so it's not that recommended. That's the major difference or the comparison I have seen in the CNN and LST models for the same data set, and I'm running it on same epoch, batch size, and same optimizer. Coming to sixth task, that is image classification. In this image classification with CNN model, I have used fashion MNIST dataset. So if I run the code, the ground truth for the 9 is okay, it's a shoe. You can see now I want this one. Actually this is the shoe which is actual value which I have chosen, and then I'm going to predict whichever the loss or whichever the loss accuracy, and then the predicted one. So in this I took the fashion MNIST, and then I took the first image of the train data and the first image of the test data, and then have scaled the data according to it, and then using the actuation functions, even I used tanh in this, and dense everything. After model fitting it, I have even plotted the graph for each and everything and predicted the model for the test data. So I got the test data is one shoe, which I have previously shown you, which is the second image because it's a test image, and I'm printing the same test data image right now. So if you look at the fashion MNIST, it will be something like this. Yeah, this is what the image would look like for the fashion MNIST. So in the test data, I think something I got image like a shoe, which is shown Nike. Let's see if I get the same thing. After completing the task, we can see the loss and accuracy graph where for the training data and test data. So the training will be for the training will be increasing in the accuracy, and there will be a decrease in the loss. And you can see the ground truth of 9, which I got the test data is 9, and here the same image is been here. Thank you.